Hello everyone, welcome to the IAS Mentor Current Affairs class. In this class, we are going to understand quantum computing technology. Nowadays, this is very important question. In prelims also already a question was asked related to quantum computing technology. In this class, let us analyze completely. Very important from the mains point of view also. You will come to know what are the various dimensions which we need to study for mains perspective. At least 3 elements are there. Identify this one. Quantum computing technology means question can be asked like what are the applications, advantages of quantum computing technology? What are the challenges that are associated with quantum computing technology with respect to India? So first one, what is it? Second one, applications or advantages. Third one, challenges. And fourth one is the way forward. Let us understand this one by one. Quantum computing technology. The traditional computers, you already know how they are looking. But when it comes to quantum computing technology based computers, the shape of the computer itself is going to change completely. We are not going to see the similar kind of computers like laptops or monitors or smartphones. They are going to change. The shape is going to completely alter. This is just beginning only. Like some of the companies like IBM, Google, they are already working. They already created prototypes of super quantum computers as well. These are. What is making it different from the traditional computing technology means, when it comes to traditional computers, it is based on bits. Bits means binary digits. Binary digits. From this BITS, from these two terms, this term emerged. What is this binary? Binary means 2 elements, 0, 1. If you see the digits, we have like 0, 1, 2, 3 and so on up to 9 digits are there. But it takes only 0 and 1. It has revolutionized the way we operate the machines. Now, it is just like a switch. If switch is off, that is equal to 0. If switch is on, that is equal to 1. So, based on that technology, so far we have operated our economy, our banking system, our security operating system, everything. Now, a new technology is about to emerge because there are certain limitations to this technology. For example, when Corona came, we have so many powerful computers, but still humanity could not develop a virus, the vaccine for the virus, coronavirus immediately. It has taken some time. Meanwhile, many lives were lost. That shows that now humanity is facing challenges so big, humanity needs solutions very fastly. So this is the first requirement of the humanity now. Otherwise, dangers are going to happen very fastly. Another example, climate change is about to taking place. Climate change is taking place. Before any damage could occur, if we don't find a solution, then humanity is going to become even extinct also. To that level, present day climate change crisis is about to happen. Again, we need to act very fastly. So one is speed. Another one, the exact solution, accurate solution is also required. That accuracy comes when you experiment very fastly, when you fail very fastly, and when you come up with a solution very fastly. That is why the present day digital computers have certain limitations. They are not able to meet the present day challenges, present day requirements of the humanity. Binary digits, zeros and ones, they are like switches. These switch nothing but with the semiconductor technology, with the invention of transistor, this digital computer shape altogether changed. Like earlier, there were vacuum tubes. Earlier, before the invention of the transistor, there were computers. But do you know how big the computers were? Entire room, single computer only. But now in a single room, you can fit so many computers, laptops, smartphones. To such a level, transistors transformed the shape of the computers. Now, new technology, that is quantum, means this is going to operate bits, but on top of it, they are called qubits. Here, this is quantum bits. What does it mean? It uses 0, it uses 1, and 0 and 1 at a time. What is this? Can we easily understand what is the meaning of this? 0 we can understand. A switch is off, we can understand. A switch is on, we can understand. But now it is 0 and 1 means the switch is neither in on position nor in off position, but in between. Still we can read some information from that position also. How is it possible? I will show you this. The main fundamental, the physics behind this is called quantum physics. When it comes to quantum physics, if you take any kind of element or atom, for example, if you take silicon atom, now fundamental level we go, atomic level. It has 3 energy levels. One energy level contains 2 electrons. Second energy level contains 8 electrons. 8 plus 2, 2 plus 8, 10. Silicon atomic number is 14. It will have 14 electrons. These are the 4. This is how the periodic table elements are organized in such manner. First one is hydrogen, second one is helium, and so on. When it comes to the electrons, these are visualized by the scientists that atom is there. When it comes to the core, here protons and neutrons are there in the nucleus of the atom, and in the energy levels, outer layers, electrons are there. Now, when it comes to the traditional computer, same silicon is used for transistor building. It has changed the humanity so big that in America, one valley is named after silicon only, Silicon Valley. That shows because their Intel corporation manufactured these chips, because of that Silicon Valley that itself emerged. Suppose if this new technology comes, that Silicon Valley may become irrelevant completely. All the computers, all the companies which are there in Silicon Valley may shut down. Completely it may become like a rust belt. Rust belt means not useful for that, not useful for anything. To such a danger, the new technology is posing for the old technology. If any hacker is able to capture this technology, then he can hack anything very easily. That's why before this technology enters into the evils, governments, industries should enter into this game. If any hacker is there to hack the government system, government should have this technology so that it becomes almost impossible for the hackers to hack the systems. That is this electron. The electron movement is deciding the flow of current. Semiconductor means if electrons flow freely, that is in on position. If they are blocked, that is in 0 position. Electricity pass on, that is 0, 1. Electricity off, that is 0. Switch. Now, when it comes to quantum, this is where please try to carefully identify this one. This is electron having so many energy levels. When they get extra energy, they used to jump from one place to the other place. You can visualize this way. Suppose if electron is there, If it is in this position, consider 0. If it moves to the higher energy level, consider this is 1. Now present day transistor, either you can read if electron is it here or here. But when quantum computing means quantum energy levels means what about if electron stay in this position also? Today if it is in this position 0, in this position 1, but electron can stay in this position also, that is between 0 and 1. How many possibilities are there? If it is 0 and 1, only 2 possibilities. If this is the 1, theoretically infinity possibilities. Consider like a bulb is in off position, 0. A bulb is in on position, that is 1. What about if bulb is in flickering position? It is not stopping also, it is not completely on also, flickering, like a tube light flickering. How many combinations will come? Sometimes it will glow very brightly, but not complete on. Sometimes it is almost about to dead, but not completely off. And somewhere in between, half glowing, half darkness. That is where this is what quantum computing means, 0 and 1 at a time. This is called superposition. That is what the term given by the scientist is called superposition. So now you see the definition. After understanding this, it is very easy to now you get the meaning or definition. Quantum computing is a type of advanced computing that uses the principles of quantum mechanics. Quantum level at atomic level, quantum mechanics, the science of how particles like electrons and photons behave at very small scales. Unlike classical computers which use bits 0 or 1, quantum computers use qubits, quantum bits that can exist as 0, 1 or both at a time, called superposition. Getting this? Now after understanding the concept, easily you can remember the definition also. It can exist, electron can exist in on position or off position or within, in between also. For easy purpose, if you flip a coin, heads and tails are there. Now when you flip the coin, finally you will see either heads or tails. But what about when it is in the air? When it is in the air, it is keep on spinning, keep on spinning. When you, how can you say? Can you say whether it is in head position or tail position? When it is spinning, it is both head and tail position. Sometimes more head, sometimes less tail. Sometimes more tail, sometimes less head. But that is how the spinning, exactly that is what the spinning of electrons, superposition of electrons is going to be considered as a source of information. Based on that, quantum computing technology is going to emerge. And obviously, you know what is the biggest challenge. Working at that atomic level itself is a big challenge. But definitely, when it comes to vacuum tubes were there, very big. Discovering or inventing a transistor is also a major challenge, but it happened. And when a first chip was created by Intel, IC404, that was called 4004, was the first commercially available chip. A chip means a computer chip on which many transistors are connected. 2300 transistors were there in the first chip. But today, how many transistors are there on a single chip? You know, billions and billions of transistors are there. How that condition is happening? Because of latest technological development. Same is the case. Quantum computing also is on the way. Whoever possesses this technology, they are going to rule the world literally. In the past also, to give you an example, gunpowder was there. There were certain kingdoms which do not know about gunpowder, but some kingdoms, they immediately adopted gunpowder technology. These, whoever possessed gunpowder technology, they ruled Europe, they ruled Africa, they ruled Asia. Example, Ottoman Empire. Later, when industrial revolution came, when steam engine came, it's very difficult to cross the oceans earlier with such a fast pace and with firearms. Now in industrial revolution, when firearms with strong navigation technologies emerged, they ruled the world. Example, English, India also became colony of English. Later, in Second World War, whoever possessed nuclear energy, nuclear bomb, they ruled the world. Nuclear technology, America was the first to get this technology. Now today you know America ruled literally since 1945. Similarly, whoever is going to possess quantum computing technology earliest, and they are going to rule the world. To such a level, this possibility is there. UPSC is also giving a lot of importance. Even our government policy is also already one mission also started how to harness this new technology called computing, quantum computing technology. So first point, meaning we have understood clearly, because once you know the meaning, then it becomes very easy to understand rest of the things. Now, one more issue with respect to possibilities. For example, if there is a hacker, now consider your nuclear sites are there. India is possessing so many nuclear sites. Now, these nuclear sites are now well protected. Well protected, and protected means what? With existing computers only. Passwords are there. That's what we call cyber security. Now, what about if enemy country or hackers wanted to destroy our nuclear facilities or nuclear sites? Now today, computers are able to crack these passwords. No matter what kind of password you keep it, the hackers are able to crack it. Now, suppose if these nuclear sites now protected by the quantum computers, now these are going to become traditional computers. If you see 70-80 years ago, there were analog computers, analog machines. Later, digital computers came. Now, whoever possesses digital computers, they rule the world. Similarly, when this technology comes, now this becomes a traditional, this becomes modern. Now, this is becoming a traditional. Now, new modern is coming, quantum computer. Now, consider our nuclear sites are protected by quantum computers. Now, if there is any password for this, if there is any password, what is the possibility? When it comes to this password, either 010101, no matter, combination is either 0 and 1 only. Now these hackers are coming up with more advanced computing technology, and they are able to crack these zeros and ones. But now, if quantum computing technology comes, now you see, either it can be 0, it can be 1. Now between 0 and 1, infinity possibilities are there. Each and every possibility can be a passcode. Now it can be changed very fastly. That's where hackers also, it becomes almost impossible to crack this combination. So password strength also increases, possibilities of cyber security increases. It becomes almost impossible for the hacker to crack those passcodes. That is where it is going to make nuclear facilities are very safe. Same is the case with the space. Our space technology, now we are talking about Mangalyaan, Chandrayaan 3, and we are talking about so many other missions related to advancing understanding about sun also, Aditya. When our so many satellites are there outer in the space, how you protect our satellites? Again, you have to protect them from this. Otherwise, enemy countries, if they possess computing technology early, then it becomes easy for them. Cracking this traditional password for the quantum computer is a dead easy task. Do you possess? That's where exactly now a new kind of possibilities are emerging, new kind of threats are also emerging. When it comes to opportunities also, if you possess this technology, very a huge change you are going to see in our economy, in our healthcare, in our education system, in our economic system altogether, in our security system altogether. That is what our mains question. Like first one, what is the definition? You understood the definition 0, 1 and 0, 1 at a time. That is the definition. Superposition, that name should be there, that word should be there, superposition. Now, when it comes to practice questions, this is how you can see. You will get an idea how questions can be asked. India needs to harvest quantum computing for strategic and economic development. Strategic means what? Protecting our military facilities, protecting our nuclear sites, protecting our military like Navy, Army and Air Force. Strategic and economic development in agriculture, in industries, in trading, in transportation, all those things. How can India's national quantum mission 23 to 31 strengthen national security and digital public infrastructure examined? Now entire India is connected online. That's what digital India we are talking. That's where this kind of question, how you answer. What are the major challenges facing India's quantum ecosystem? Suggest a time-bound way forward. What are the challenges? Now we know the technology. Definitely we know this technology is going to revolutionize. But how to get it? How Indians can harness it? How Indians can get that technology earliest? What are the challenges? Discuss how quantum technologies can support disaster management and climate resilience in India. Do you see this? Every problem, whatever problem that we are currently facing, quantum computers may give solutions very fastly and very quickly. Now, applications one after the other. Let us see. Now it becomes easy once you know the concept. It becomes easy to understand one by one, because the same concept you have to apply in different fields. Simple. For example, cyber security and cryptography. It's like you have to give one after the other the dimensions. For example, if the question is like this, what are the applications or advantages? If the question is like this, in your mains paper, you will have paper like this. Border will be given. You have to write the answers within this boundary. Here you should not write anything. In that boundary also, border also, you should not write anything. For example, question is about explain the applications or advantages of quantum technology. Now you are going to answer it. First you will give the definition. Second one, you will put a heading that applications. Now once you give the heading, then one by one you are going to give number one. That's what we are going to see. First one, cyber security and cryptography. I will write simply cyber security. Now below that you will have only 2 pages or 3 pages. You cannot, whatever information I am giving here, this entire information also you will not be able to write there. Space will not be there, time also will not be there. Cyber security. Then you will write 1, 2, 3 like that. Then second heading, healthcare. Third heading, defense. Likewise, let us see one by one. So when it comes to cyber security, just now I have explained, when it comes to the password management in traditional or digital computers, now earlier it was difficult to crack, but nowadays it is becoming very easy for the hackers to crack it. Even for enemies, when there is a war with enemy country, it becomes easy for the enemy countries to destroy our computers and our assets. India faces constant challenges in cyber threats and data breaches. Even at the highest level, Prime Minister office, ministerial level, websites are also getting hacked. That shows how vulnerable we are. Quantum computing can break traditional encryption, but also create quantum safe encryption. So it is not that we only get affected. If we want to attack in the war, then our quantum computing power easily decrypt whatever enemy encryption is there, and also we can protect our assets also with strong encryption. That's where when you are writing, just you have to write with a strong encryption. Quantum computing technology ensure our assets are protected If it is required, we can destroy the enemy assets. That is how. What is the example? Like defense and critical infrastructure like nuclear plants, banking networks can adopt quantum key distribution. This is what quantum key distribution means, this only. It's not going to be 0 or 1. It is going to be 0, 1 and infinity possibilities between 0 and 1. That strong key password is going to be very, very protected, very, very strong. It becomes very difficult for the opponent to crack it. Quantum key distribution. So secret codes between two people using quantum physics so that no one can secretly listen in. That is why if someone spies, you will know instantly. Even if you come to know that something happens, immediately you will come to know, you will immediately change it. Strengthening digital India and safeguarding financial or strategic assets. That is all. Second one, healthcare and drug discovery. So second one, you are going to write healthcare and drug discovery. Already I started this topic by saying coronavirus came. Despite having this much technology, this much advanced, so-called advanced economies like America, Europe, they were also not able to come up with a solution and they completely collapsed during coronavirus time period. Entire economies collapsed. Reason is traditional computers are not able to immediately find a solution for the virus because virus is mutating very fastly. But our computers are working with zeros and ones, but reality is not like that. You consider, for example, 0E means midday, midnight, where complete thick darkness. You consider 1 means very midday. But is life is like that? Between midday and midnight, so many possibilities are there. For example, dawn and dusk. How you consider? Do you call is a complete day or do you call complete night? In the early morning, that is dawn. In the evening, dusk. Now, how you describe it? It is neither day nor night. That is what real life is. That's where when mutating happening at a very fast rate, coronavirus, digital computers are not able to capture that moment. Whereas quantum computers is all about that capturing that mutation only. Because it is not about 0 and 1. It is about continuous change. Immediately quantum computers can capture that mutation. Drug delivery or drug discovery is also possible. That is how. Healthcare and drug discovery. Next one, agriculture and food security. Agriculture and food security. Next one, agriculture and food security. Again, agriculture is still India's largest livelihood sector. These algorithms can optimize how to water management. I'll draw. Third one, agriculture. What are various challenges we have? First one, agriculture means we require water management. Whenever there is rainfall, we will get lot of water. And if we don't know how to store it, then within few months, then we enter into shortage of water. That water management becomes easy if we have better algorithms, better solutions. Next one, soil productivity also can be easily assessed. Based on the soil testing, we can easily adapt what kind of crops are better for a particular soil. If soil productivity is coming down, then we can select some kind of crops which will strengthen the soil productivity rather than weakening it. That kind of solution. Now, what about fertilizers, pesticides? Instead of using discretely, that means farmer do not know how much pesticide is required, how much fertilizer is required, because that kind of information is not there. Instead of using very discreetly, and we are going to become very accurate and very precise. Precision farming is going to happen. Do you see this? It's all about, if you compare with analog computers or previous methods, digital computers are modern methods, advanced methods. That means the accuracy, information becomes more accurate and more precise. That's what is all about. Previous machines, that precision will increase in digital computers. Now that precision increased in digital computers, now it will increase even further in quantum computers. For example, if you take a flower, how flower blossom? Sun is there, you consider sunflower. Now this flower, it's like a quantum computer only. How? It is not that suddenly one day when you see there is no flower, suddenly next day flower blossom. Do you think it is happening like that? Is our children suddenly today they are born, tomorrow they will become elders? No, they grow very gradually. Flowers also bloom very gradually. Now that is where exactly quantum mechanics or quantum physics is all about. According to the availability of sunlight, according to availability of water, according to availability of fresh air. If it is a polluted air, these flowers will not bloom, plants will not grow properly. Jagdish Chandra Bose, he proved that even plants also have life like animals, like human beings. If the good environment is there, plants also grow very healthy manner. Now, what is happening here? According to the light, according to the water, according to the pollution levels, the growth of plant is decided. That is calculated like this only, gradually. Now, quantum computers can assess how much sunlight is there, how much water availability, how much pollution level. Depending on that, what kind of productivity can come after 2 months, 3 months, forecasting even rainfall also. Depending on that, easily we can get solutions for the agriculture sector. That is how quantum computing is going to change agriculture also. Every field, whatever you are talking about in today's context, you apply same thing. Now, finance and banking. Finance and banking, few years ago, there was no concept of UPI. There was no phone pay, there was no UPI. But today, everyone is having UPI, Google Pay or phone pay. Now, what is this? Earlier, everyone have to use coins, either gold coins, silver coins or copper coins. There was no paper currency. When paper technology came, paper currency came. Now, when digital computers came, digital currencies came. Don't you think economies improved with changes in the currency? Obviously, it changed. The interaction changed, economic activities improved, and economy also improved. Similarly, new kind of currencies may come, which becomes easy for the management. That is how new technologies are going to change. Quantum computing technology is also like that. That is with respect to currency. But with respect to the safeguarding bank accounts from the cyber attacks or during wartime period from the enemy attacks, computers, quantum computers will protect these finances very safely. India has a vast financial sector with UPI, stock markets and global investments. Protecting this infrastructure, financial infrastructure is very essential. If stock market collapse, suppose if there is a hacker, if there is an enemy who manipulate the stock market, suddenly there will be panic, and if people started drawing, entire stock market will collapse. Then it takes many years to revive. And meanwhile, many things will change. Many challenges are going to come for the government. If financial sector is under stress, existing countries are going to collapse. That's what many, now if you take Nepal also, if you take Bangladesh also, if you take Sri Lanka also, if you take present day Pakistan also, why so many protests are happening? Because of lack of economic development. One reason behind it is financial sector and banking sector is not very strong in those countries. They are there, but not like very strong, resilient like America, Europe or India at least. In case of India also, we have very strong, resilient banking financial sector. That's why we have to protect it. If we are not able to protect it, then it is a danger for us. Next, defense and national security. Strategic challenge. We have long borders, we have coastline, we have space assets, we have to protect it. Again, protecting with quantum computing technology becomes very easy, and we can protect our assets. Climate change and disaster management. When it comes to climate change and disaster management, we do not know whether El Nino comes or not, La Nina comes or not. These are the geographic climate related topics. sudden floods will come, sudden droughts will come, sudden temperatures rise, sudden temperatures fall down. Now, when it is happening, you have to capture this moment very fastly. Then be ready, strongly have some kind of management, disaster management policy, so that our lives will not last. Human lives will not last, livestock lives will not last, our forests are not going to affected. Then only we can live with prosperity. Otherwise, one climate change can wipe out many people. For example, sea levels are rising. There is a small island called Tuvalu. Now, after few years, we may not see that island at all because it is going to be submerged under sea. Now, what will happen to those people? Their culture, their economy, their political system, everything disturbs. Now, the people have to run away from there and to enter into some other countries. Now, if they enter into some other countries, they will not feel that that is their land. They always feel that they lost something and they are just to protect their lives, they are taking refuge in. They will not be considered as people who own the land, rather they become refugees in the world. That is how the entire danger is there for climate change. When quantum computers are there, they can easily guess sea level changes, monsoon changes in the pattern, rainfall pattern change, then temperature changes, how much sea level is rising due to ice melting, then water in the rivers also can be guessed easily during particularly during summer season. If you take Vidarbha region, their water scarcity is leading to the suicides of the farmers. That kind of dangers can be averted with quantum computing technology. Next, logistic and smart cities. Smart city solutions like slums management, water management, electricity management, transportation management, all these things can be streamlined more efficiently. Resources can be utilized more efficiently. Energy resources can be efficiently utilized with quantum computers. Then with growing population, the cities have become very not able to provide basic amenities also to the city dwellers. That problem can be resolved. Space research, then government pushes. Already one mission also started. That is how it is going on. Now, when it comes to compare, presently India is not able to become master in this technology, but our past is showing if we invest now, then it is going to give yield or benefit after some time. For example, if you take two things, don't you think today in space sector, India is a leader or not? Yes. Space. Today, India is one of the top leaders. Our ISRO has more success ratio than any other such kind of organizations. Many countries are looking towards India to launch their satellites. That kind of trust ISRO has built over a period of time. That is today. But do you think this kind of success happens all of a sudden? No. It happened long ago. ISRO established in 1969. In 1950s onwards, Indian government has taken steps to improve the space technology. Till the time, since the first satellite launched by Russia, Sputnik, that was the first satellite. Indians also started investing in this. In 1960s, ISRO also established. In 1970s, we also started launching satellites. Initially with the help of Russia, later our own satellites. By 1990s, 2000s, we started becoming a self-sufficient, self-reliant. Today, we have become the leaders. And today, we are very much confident about our space assets and space missions. Do you see? That's what the steps taken long ago now yielding the result. Same is the case if you start now quantum computing technology. After 2 decades, 3 decades, you are going to see the benefits. Same is the case. Don't you think in nuclear technology, we are now confident, self-reliant? Yes, but that is the effort since 1944. So in 1944 itself, Indian government or individual scientists like Homi Jahangir Baba, they started working in this field In 1950s, nuclear facilities, research centers started. Now today we are able to have our own nuclear facilities. We have even nuclear weapon capabilities also. That kind of possibilities will come when we invest today, and after 2-3 decades we are going to get the benefit. That is where visionary leadership, that is where futuristic leadership. That's why Indian government also started a mission, national mission on quantum technology already started. It is going to take some shape after few years. But challenges, advantages are fine, but challenges are also there. When it comes to challenges, it requires huge funds. Today, we are still facing, our people do not have basic hospitals, basic school facility infrastructure, basic roads also, basic connectivity. Now, whether you use the funds for these basic things or you use it for advanced things, which will give result after many decades. But today, people have to live, people have to survive from these basic hospitals. That is where dilemma, when resources are limited, this dilemma always comes, whether you invest for the future or whether you invest for today. If you use your resources for today's consumption, then every day you are going to struggle. If you invest for the future, for today you are going to suffer, but after some time you are going to get the benefits. But that is the big dilemma. High cost of infrastructure is required. That is where one of the major challenges. Next, lack of skilled workforce. To work on this, we need people. Again, when it comes to our education sector, the best talent is taking the destinations, either Europe, America, best places. When it comes to India, we do not have that ecosystem where our talented, skilled people will stay and do research here. That atmosphere is required. That is what lack of skilled workforce. When it comes to this also, mathematics, computer science, engineering related skills are required. We have to create that kind of ecosystem. Next one, foreign technology. We have to depend on others whenever we have to go for any new technology. That's where if we are not self-reliant, then we have to continuously depend on foreign countries. They will not give their best. They will give what they consider not very dangerous, even if they give the technology to us. But they will not give their best. And again, if they don't give the best, we cannot further develop with the best possibilities. That is another challenge. Fragmented research ecosystem. Multiple universities, institutions work in silos, different independently. Now, connecting the dots is required. Integrated research required so that this technology becomes reality. Next, competition from global powers. Already some powerful leaders are already investing, like China, USA. They are investing. They will get the first benefit. And to match the technology of those countries, it takes time. That is another one. Private sector participation limited, because private sector participate when there is profit immediately. But if there is no profit in the near foreseeable future, then they will not come together. They will not come forward to invest in it. Brain drain. Best talent is choosing other countries as the destination. Because in India, if there is ecosystem, no Indian wants to go out. Because if there is an ecosystem, no one wants to leave the home. If we provide that ecosystem, everyone are happy to work here to contribute their best here. So that we have to address. Long gestation period, it takes some time, till the time you have to survive. That is how the challenge. And there are certain number statistics. You can go through this PDF you will get. Like National Quantum Mission funding 6,000 crores for 23-24 to 30-31. Number of quantum startups over 40 in 2 years. Startups supported under first phase 8 startups. Grant to each startup up to 30 crores. Quantum computing hardware tested 6 qubit computing processors. Latest Indian quantum computer launched 25 qubit superconducting system. That's what. When it comes to superconducting means, you can operate these qubits like 0 and 1, even at room temperature you can operate the computers. But quantum computers cannot be operated at room temperatures, because electron energy levels are very fast. If you have to control that energy levels, you have to reduce the temperature. That's where cooling mechanism is required. That is where superconducting mechanism is required, where temperatures are at very low. that technology is required. A lot of funds are required to maintain that level. Then market revenue, global comparison, patent positions, and so on. So this way, you can get some of the statistics related to the present ecosystem of quantum computing. Way forward means same thing. Whatever challenges we are having, just you write the opposite one. Like strengthen research ecosystem, strengthen hardware infrastructure. That is why today we are having even computer chips also. India is trying to manufacture our own chips so that we need not to depend on other countries. That is how. Skilled workforce, you build it. Public-private partnership, secure funding, long-term commitment, global collaboration, and so on. Focus on quantum security. So this is how, whatever challenges we are there, way forward means just opposite to that. If we are having something less, that means we have to improve it. This is how you have to handle this particular topic. Similar kind of structure will come any kind of technology. For example, if you talk about any latest technology, clean energy related to hydrogen related and technology, if we require, again same challenges will come, same applications will come, same way forwards will come. All right. So first you identify the technicalities so that you can explain in the beginning definition, and later when it comes to applications or advantages, challenges, way forward are going to be very, very standard one that you have to give examples from different fields. All right. This is how quantum computing technology. This is one of the very, very important topics nowadays. Already in prelims also this question was asked. In mains also possibilities there. Already there was a question related to artificial intelligence. Explain the concept of artificial intelligence, how artificial intelligence will enable or help with respect to healthcare. Same question you can apply to the quantum computing also. Explain the concept of quantum computing technology and explain the applications. In this way, you can get the questions. All right. Thank you. Thank you very much.